Hello, in this video I'll be going through some questions using the equations of motion again. So this is a part 2 to the first video that I published on this channel. So in the last video we went over questions that used these equations. So the first one is V equals U plus AT. V squared equals U squared plus 2AS, and S equals UT plus a half AT squared. So these are the equations of motion. If you haven't seen the first video, I'd recommend go watching that one because it's going to be exactly the same as this video. But if you haven't seen it, you don't need it to watch this one because I'm going to explain basically what terms and basically what the letters in each of these equations mean. And yeah, we'll do some very similar problems. Okay, so looking at these equations, this is equation 1, 2, 3. As you can see, they're all pretty different. And if you have 3, if you get given 1, 2, 3, you can find basically the other 2. So as you can see, there's 5 variables. So there's V, U, A, S, and T. If you have 1, 2, 3, you can find these 2. Okay, so all you need to have is 3, and using those 3 equations, you can solve them. Okay, so let's just get over what the letters mean. So V is the final velocity of an object. U is the initial velocity. So initial means start. So basically, if a car was, it starts at rest, and then over here it's 10 meters per second. The initial velocity is 0 meters per second, and the final velocity is 10 meters per second. Okay, so that's what that means. Next term is A. So A is acceleration. Okay, so typically that'd be like gravity, or if a car is accelerating, etc. But typically we use gravity. Unless specified, if assume gravity is negative 9.8 meters per second squared, but some questions it'll ask you to use negative 10 meters per second squared. Okay. Next one is T. So T is pretty obvious, it's time. And S isn't so obvious. S means displacement. So displacement is like distance, but it's a vector quantity. Okay. This has the units meters per second. This has the units meters per second. This has the units meters per second per second. This has the units seconds, and this has the units meters. Okay, so that's what each of the letters mean in these equations. Best way to really use these equations is just to start doing problems, and you'll see what I mean when to use which equation. So if you're like half understand what all these mean, I reckon give this question a go, and I reckon it will help you understand it quite a bit. Alright, so this is question 1. A rock is dropped off a cliff and it takes 0.9 seconds to hit the sea. How high is the cliff? So if you want to have a go at this question, feel free to pause the video and have a go. Alright, straight up, I'm reading my sentence. It's trying to get a picture in my mind. So there's a cliff and a rock's been dropped and it's falling into the sea, pretty much. The time it takes for the rock to go down to here is 0.9 seconds. So straight up we have T. T is 0.9 seconds. What else have we been given? We've given this word dropped. So if you drop something, its initial velocity, like if you just drop something, for the first moment, its initial velocity is 0. And it only gets pulled down due to gravity. So at the top here, when it says dropped, that means U equals 0 meters per second. So at the moment it's dropped, its initial velocity is 0 meters per second. Okay, so U is 0 meters per second. Down here, it have a final velocity, but we don't need to find that. I'm assuming this is happening on Earth, so acceleration is G, which is negative 9.8 meters per second per second. Alright, and we have 3, so that means we can find the other 2. but this question only asks how high the cliff is, so all we got to do is find its pretty much its distance. And it says the rock is dropped off a cliff, so that means the rock was probably dropped like right here at the height of the cliff. Okay. Alright, so I hope you got that good picture in your mind. Now we got to do the math. Alright, so first we're going to write out our equation. So we have the first one, v equals u plus at, v squared equals u squared plus 2as, and s equals ut plus a half at squared. Okay, so what do we have? U's in all of them, so we can use any of them. Accelerations in all of them, but t is only in two of them. So t is in this one and in this one, so we're not going to use this one at all. And we're looking for s, so we're going to use this equation here. Okay, so we're going to discard the others and have a go at this. Alright, so we don't need to rearrange anything because it's already in terms of s, so all we've got to do is plug in our stuff into here pretty much. So s is equal to 0 times by 0.9 plus a half times negative 9.8 times by 0.9. Okay, s equals, put that in your calculator. It will give you a negative number because s is displacement, so you can have a negative distance, but that just means like a direction pretty much. With respect to like an origin point, so it's assuming this is like the origin, this is like 0, 0. Okay, so it will give you a negative number. That's fine. You just got to take the absolute value of that number. So a half times negative 9.8 times 0.9. You should get approximately. Did I do that right? Oh yeah, squared. So you should approximately get negative 3.969 meters. So the distance, the height is 3.97 meters if you're rounding. Okay, so that's the answer. So that's the height here. Alright, cool. Alright, let's go on to the next question. If you have any questions about this one, type which question you had trouble with in the comments and I'll try and respond to you. Alright, next question. A ball is thrown vertically upwards with an initial velocity of 24.5 meters per second. Calculate the time for the ball to reach its max height and the gain in height of the ball during this time. So if you want to have a go at this question, feel free to pause the video and have a go. Alright, so let's just draw a diagram of what's happening. So a ball has been thrown up and it goes back down. So it has an initial velocity. So u is 24.5 meters per second. So we're going to put that over here, 24.5 meters per second. So it's gonna fly up, it's gonna hit a max height, and it's gonna fall down. Okay. So what we got to do is we got to calculate how long it took to get to the max height, and we're going to determine the max height. So we're looking for t and s. Okay. Up here. So if you throw something up, when it reaches the max height, its velocity will be 0 for a moment because it's got to fall back down. Okay. So up here, v is 0 meters per second. So the final velocity at this point here is that. And the time it goes to go up, so the time it takes from it to go here to there, is the same it will take for it to fall back down. So, take out the time taken for the ball to reach max height. Okay, so we only need the time it takes to go up. Alright? So using that fact, we know that v at the top is 0 meters per second. We also got u, and we got gravity, so negative 9.8 meters per second. Alright, now let's write our equation. So we have v squared equals u squared plus 2as. We also have v equals u plus at, and we also have s equals ut plus a half at squared. Alright, we have u, so we can use any of these equations. We have v, so we can't use this one, and we have gravity. And we're trying to find time and displacement. So we're going to have to use both of them. So we're going to use this one to find s and this one to find t. Okay. So I'm just going to get rid of this bottom one for now. And I'm going to move this stuff around. So I'll move that over there. So let's find our displacement first. So we're going to rearrange this equation here in terms of s. So v squared minus u squared equals 2as. Divide by 2a. Divide by 2a. Therefore s equals v squared minus u squared all over 2a. Alright? Now we're going to plug in our numbers. So s equals 0 all squared minus 24.5 all squared. Divide by 2 over negative 9.8. Using a calculator, you'll approximately get, where's my calculator gone? Whew. So using a calculator, I just found it. There we go. 0 squared minus 24.5 all squared. 2 times negative 9.8. You'll approximately get 30.625 meters. Alright? Now we're going to use this equation here to find the time. So all we've got to do is make time the subject. So v minus u equals at. Divide by a. Divide by a. So therefore t equals v minus u over a. Plugging in your numbers. 0 minus 24.5 divided by negative 9.8. And time is approximately, using our calculator, 2.5 seconds. Cool. Alright. You get full marks if you did all that. Had any questions? Leave some in the comments, okay? Alright, have a go at this next one. So a stone is dropped off a cliff. How far will it have fallen within 4 seconds? Take gravitational constant g to be 10. Then find its velocity. So this question has 2 parts. Have a go if you want to. So pause the video if you want to have a go. Alright, straight up, stone is dropped. And it's dropped off a cliff. So it's falling down here, and yeah. So it says, you see the word drop, initial velocity is 0. Okay? That's what that means. Alright? So straight off the back we have that. 0 meters per second. We also have a time, 4 seconds, and it's asking our gravitational constant be 10. So g is negative 10 meters per second Alright, we have 3, so we can find what we're looking for. So we're looking for a distance, so we're looking for s, and we're looking for the final velocity. So look in the distance it travels here, and the velocity at the bottom here. So let's write out all of our equations. So v squared equals u squared plus 2as. S equals ut plus a half at squared. And v equals u plus at. Alright? We have u, so we can use all of them. We have t, so we can only use this one or this one. And we have a. Alright, so we're looking for distance. And we're looking for final velocity. So we're going to have to use this one and this one. So both of them. Alright? So we don't need this top one anymore. And let's move that there. And let's move this here. Alright, first off, let's just find the distance it goes. Because we don't need to rearrange this at all. And we don't need to rearrange this. Because they're already the letter we want, pretty much. So all we got to do is plug in our letters for the numbers we've got. So s equals 0 times 4 plus a half times negative 10 times by 4 all squared. So using your calculator, you should approximately get negative 80 here. Now this is displacement, so if you want the actual distance, just ignore the negative sign here. So the height of this cliff is 80 meters. Alright, so this equation now, so v equals 0 plus negative 10 times by 4, so v is negative 40 meters per second. The reason we have this negative sign is the direction of the velocity. So since it was dropped up here, it's going to have a velocity vector going down like this. Okay? Cool. Alright, that's that question answered. You get full marks if you had all that. Alright, have a go at this one. So if you want to have a go, feel free to pause the video. A car accelerates uniformly from 13 meters per second to 31 meters per second while entering a motorway, covering a distance of 220 meters. Calculate the acceleration of the car and the time taken for the car to accelerate. So if you want to have a go at this question, feel free to pause. Alright, so we've been given two velocities. So our initial velocity is 13 meters per second, and our final velocity is 31 meters per second. Okay, so u equals 13 meters per second, and v equals 31 meters per second. Okay, cool. While entering a motorway, we've also been given a distance. So our displacement is 220 meters. Alright, so we want to find A and T, okay? And since we have three of these, we can find the other two. So this is the picture we're looking at. So a car is initially traveling at 13 meters per second, and sometime later it is traveling at 31 meters per second. Okay? So it's accelerated sometime in here, and there's some time it's taken to go from here to there. Alright? So that's the picture we're looking at. So let's write out our equation. So we have v squared equals u squared plus 2as. We also have v equals u plus at, and we also have s equals ut plus a half at squared. Alright? So we have a u, so we can use all the equation. We have a v, so we cannot use this one. We're not going to use this one. So we want to use this one or this one. We also have S, so we're going to use the top one here. Okay, but since we have to find two things, once we found our thingy in here, we can use either one of these equations. Alright? So let's just move this one over here. And let's find our acceleration. So let's just make A the subject. So v squared minus u squared equals 2as divided by 2s. So A is v squared minus u squared all over 2s. Plugging in our numbers, 31.0 all squared minus 13.0 all squared divided by 2 times 220. Putting that into your calculator, you should get an acceleration of approximately 9/5 meters per second, or when you simplify that, approximately 1.8 meters per second. Okay. Right. So have we finished the question? No, we haven't. We still got to answer one last part. So we need to find the time it took. So we know the acceleration now is 1.8 meters per second, but we still got to find the time. So we can use either one of these equations now. Since this one only has t in one spot and this one has t in two spots, I'm going to use this equation. So I'm going to rub out this second one. Okay. So I'm just going to make t the subject of the formula. So I'm just going to go v minus u equals at divided by a. So therefore t equals v minus u over a. Plugging in our numbers, 31.0 minus 13.0 all over 1.8. Using your calculator, you should get a time of approximately 10 seconds. Okay, we've answered the question, so you get full marks if you did all this. Okay, you could have used the other equation, but it would have taken a bit longer, and you probably would have had to use the quadratic formula. Alright, fifth and last question. A car accelerates from rest to 3 meters per second in a time of 4 seconds. How far has the car traveled? So I've probably messed up my English a bit there when writing the question, because that could get a bit confusing. So if you want to have a go at this question, feel free to pause the video and have a go. Alright, so basically what this is saying is a car's at rest here, and a couple 4 seconds later he's traveling at 3 meters per second. So that gives us a u and our v straight up, and it also gives us a time. So u is 0 meters per second, v is 3 meters per second, and t is 4 seconds. So all we gotta do is find s. That's all it's asking for. It's not asking for acceleration, right? So, we might need to find acceleration. Let's just find acceleration, because I'm going to take you the long way. There might be a shorter way to answer this question. So I'm going to find acceleration first. So this is write our equation. So v squared equals u squared plus 2as. V equals u plus at. And s equals ut plus a half at t squared. Okay, so looking at our equations here, if you want to find s, you're going to need acceleration. So this question was a bit sneaky in the fact that you need to find two things, but the question's only asking for one thing. So in order to find s, you need to find a, because the equations where you use s has acceleration in it. So you need to find a first, alright? So we're just going to use this equation here because we have v, u, and t. Okay, so v equals u plus at. So therefore v minus u equals at divided by t. So acceleration is final velocity minus initial velocity over the time. And that makes sense because the definition of acceleration is the change in velocity over the time. And that is pretty much that. So that's just a little side thing as well. Alright, so let's just plug in our numbers. So acceleration is 3 minus 0 divided by 4. So acceleration is 3 over 4 meters per second Hold up. Let me just check my math. Let's just check, because I didn't have that before. A half times. Sorry, I think I've just made an error. I don't want to confuse you guys. From rest in a time of 4 seconds. Okay. I think I've written... Okay, so I think I've written my question wrong, because on the question I originally wrote, I think I wrote this as 3 meters per second. Okay, so I think I'm just going to leave this question. I'll come back to it and I'll make another video on this, but for now I'm just going to cross this question out, because I've written it wrong on my sheet of paper than I have on here. So I've accidentally made two different questions. And I'm just going to... Alright, sorry about that. If you want any more questions like this, feel free to like and subscribe. Yeah, thank you for watching. See ya.